Algebra Review Part 2. The bulk of this review will be covering factoring. Now at this point in your math education, you really should have mastered factoring. This will just be a quick overview of the different types and methods for factoring. If you need more help on factoring, you maybe need to get on the internet and find some tutorials, because by the time you get to pre-calculus, you really should have it mastered. The first type we're going to look at is greatest common factor. And typically, every factoring problem you come upon, you should check and see if there's anything that all the factors can divide by. So for this example, I see that 3, 9, and 15 all divide by 3. So I know that's going to be part of the greatest common factor. They also have an x. Every term has an x. So I can divide that out. So now I'm dividing every term by 3x. It's sort of like the distributive property in reverse. So the 3x is out front, and when I divide, I'll be left with x squared plus 3x minus 5. So every factoring problem you come upon, you always want to check and see if there's anything that divides out of all of the terms. The second type of factoring is difference of squares. If you have a perfect square minus a perfect square, then you find the square root of each term. In this formula, it would be a and b, and you have an a plus b in the parentheses and an a minus b. So in the first example, the square root of 25 is 5, square root of x squared is x, square root of 9 is 3. So in factored form, it would be 5x minus 3, 5x plus 3. And it doesn't matter if you put the minus first or the plus first. Has to be perfect squares, has to be a subtraction. 16x to the fourth minus 1, the square root of 16 is 4. Square root of x to the fourth is x squared, and the square root of 1 is 1. So that would factor into 4x squared minus 1 times 4x squared plus 1. But if you look in that first parentheses, I have another difference of squares. The square root of 4 is 2, square root of x squared is x, square root of 1 is 1. So that part will become, the 4x squared minus 1 will become 2x minus 1 times 2x plus 1. The 4x squared plus 1 has to just stay the same because it's a plus, and it has to be a minus to do difference of squares. So one hard thing about factoring is just because you've completed one step doesn't mean that it's finished. You always need to look and see if you can do anything else, if you can go farther. Trinomials come up often. So for the first example, trinomial just means it's made up of 3 terms. If you don't have a number in front of your x squared, it's a much quicker and easier problem. So I look at the back term, negative 28. I think of all the things you multiply to get 28. 1 and 28, 2 and 14, 4 and 7. Because the 28 is negative, I know that one of my factors has to be positive and one has to be negative. So I want to pick the pair that when I combine them, I end up with a negative 3. That would be 4 and 7 if the 4 is a positive and the 7 is a negative. And so in my little factored parentheses, I'll have x plus 4, x minus 7. You can always check the factoring by multiplying your answer back out. If I FOIL x plus 4 times x minus 7, I'll end up with x squared minus 3x minus 28. So you can always check your factoring. The second example is more difficult because we have a number in front of the x squared. It's a coefficient of 3. And there is more than one method to do this type of problem. If you do it differently than I do and you get it right, that's fine. If you do a guess and check method, that's actually faster. But some people have a hard time with guess and check. So what I do is I multiply the first number times the last number. 3 times 5 is 15. I think of all the things you multiply to get 15. 1 and 15, 3 and 5. And again, I'm trying to get the middle number. I'm trying to get a positive 8. So I would choose the 3 and the 5, both positive. But I can't just go straight to my parentheses now. I'm going to rewrite the 3x squared and then the 8x is going to split into the 3 and the 5. So plus 3x plus 5x, and then bring down the plus 5. Now I'm going to do grouping, and we're going to look at another grouping problem in a second, but I'm going to group together the first two and the last two and take out the greatest common factor. Out of the first two, what they have in common that I can divide out would be a 3x, and dividing out a 3x would leave me with x plus 1. And then here I have a plus, so here I have to have a plus. Out of 5x and 5, I can divide out a 5, which would leave me again with x plus 1. So what you have in parentheses should always be the same. If they're not, you've done something wrong. Write that down. And then the second parentheses will be these outside numbers, 3x plus 5. And the order of that could be swapped around. And again, you could FOIL that to check it. Grouping, you have 4 terms involved when you do grouping. So I'm going to group together the first two and the last two. Out of the first two, a common factor is x squared. And if I divide out an x squared, that would leave me with x minus 5. And it's a plus, so I write a plus. Out of 2x and 10, I can divide out a 2, which also leaves me with x minus 5. So again, what you have in parentheses should be the same. X minus 5, and then the outside, x squared plus 2, goes in the second parenthesis. Or you could have those swapped. It could be x squared plus 2 times x minus 5. Now sometimes, and we already have done one problem like this, there are multiple factoring methods involved. When I look at x to the 4th minus 6x squared minus 27, it's a trinomial, but the trinomials we were doing had an x squared. You still do it the same way. If I look at negative 27 and think of all the things you multiply to get 27, 3 and 9, and I want to end up with a negative 6. So that would be a positive 3 and a negative 9. So before we wrote x plus 3, x minus 9. But because this is an x to the 4th power, our x's have to be squared. Then if you look at what you've written, hopefully you'll recognize that x squared minus 9 is a difference of squares. The square root of x squared is x, the square root of 9 is 3, so that part can break down farther. X squared minus 9 becomes x plus 3, x minus 3. This is a grouping problem because it has 4 terms, so we'll group together the first two and the last two. Out of the first two, I can factor out an x squared, which would leave me with x plus 5. Now I have a minus, so I need to write a minus here. Out of 4x and 20, I can divide out a 4, but I'm dividing by a negative 4. So negative 4x divided by negative 4 would be positive. Negative 20 divided by negative 4 would be positive 5. So I have x plus 5 times x squared minus 4. Now, x squared minus 4 is a difference of squares. So x squared minus 4 will turn into x plus 2, x minus 2. The factoring method we're going to look at is sum and difference of cubes. If you have perfect cubes, whether they're added or subtracted, then you can see these formulas for them. And the letters in the formulas are the same. The A and the B are actually the cube roots of the original. And then the way the signs go, there's a little thing you can remember. You see that in this first one we have a plus, so that's the same as what you started with. There was a plus. And then the next sign is opposite of what you started with. And then the last sign is always positive. So it's same, opposite, always positive. SOAP. And then if you look at the second formula, same thing. The first sign is the same, then opposite. Oh, I made a mistake. That should be a plus. And then always positive. So if I'm going to factor x cubed minus 27, the cube root of x cubed is just x, so that's where the a is in the formula. The cube root of 27 is 3, so that's like the b in the formula. So the first parentheses just has the a and the b. Then you square the a, you multiply them together, you square the b. Now my signs, same, opposite, always positive. Comes into play when you're simplifying rational expressions. That's a fraction of a polynomial over a polynomial. And you always want to factor these first. So on the top of our fraction, we have a trinomial, x squared plus 2x minus 15. I look at negative 15 and try to figure out the factors that would get me a positive 2. So that would be positive 5 minus 3. On the bottom, looking at 30, I need the factors of 30 that will get me a positive 11. That would be a positive 5 and a positive 6. Now, once they're factored, you can cross out common factors. The x plus 5 over x plus 5 can cross out, and you're left with x minus 3 over x plus 6. You cannot cross out the x's. You cannot reduce the 3 and the 6. The 3 and the x on top are sealed together with that minus. They can't be pulled apart. The 6 and the x on the bottom are sealed together. Similarly, at the very beginning of the problem, you might be tempted to cross out the x squareds. You can't do that. They're sealed up with those pluses and minuses. It has to be an all or nothing situation like with the x plus 5s. Now we're doing a subtraction, and we still want to factor. So x squared over and x squared minus 9 is x plus 3, x minus 3. Whenever I subtract a fraction, I always seal off the second one in a parentheses to help avoid sign errors. Now, I need a common denominator because I'm subtracting fractions. They both have x minus 3, but the first one also has x plus 3. So I can put an x plus 3 in the bottom, but if I put one in the bottom, I have to also put one in the top. So I've got x squared over x plus 3, x minus 3, minus, and now I'm going to FOIL the x minus 5 times the x plus 3. So when I FOIL that, that will give me x squared, outside and inside would be minus 2x, and then minus 15 over x plus 3, x minus 3. Now I can combine the fractions. The minus that's on the outside of the parentheses I will distribute, and that's why I have the parentheses, to help me remember that that subtraction affects everything in the second fraction. So we'll distribute the minus, put all the fractions together, x squared minus x squared plus 2x plus 15, all over x plus 3, x minus 3. Then the x squareds would cancel, and the final answer would be 2x plus 15 over x plus 3, x minus 3. Then lastly, just some little reminder type things. Remember that when you are dividing fractions, you flip the second fraction over and multiply. Then this second reminder is a little algebra trick that comes up from time to time. If you have something that looks like a minus b over b minus a, they almost look exactly alike except the order is swapped. You can fix that by factoring out a negative 1. If I divide b minus a by negative 1, it's going to take the b and make it negative. The a will become positive, and then the top and bottom will be the same. I can just cross out the a minus b's, and I'm left with 1 over negative 1, which is just negative 1. So that's a little trick that comes up sometimes. Make sure you look over in your book the part about rationalizing the denominator and review that a little bit. And then there's also a section about avoiding common errors, and the one that I see most often is that when you have a plus b squared, if you have something in parentheses and it's squared, you cannot just distribute the exponent into the a and the b if you have addition or subtraction. When you square something, you multiply it times itself. So a plus b squared is a plus b times a plus b. And when you FOIL that, you'll see that you have a squared plus 2ab plus b squared. So be very careful about that.